Did geocentric model explain polar nights plausibly? Yes, the geocentric model offered a completely plausible and geometrically accurate explanation for polar nights. In fact, the explanation was so robust that ancient astronomers like Ptolemy and Pytheas could calculate the duration of polar daylight and darkness long before anyone visited the poles. Because the geocentric and heliocentric models are geometrically equivalent regarding the relative angles of the Sun and Earth, the mechanism for polar nights in the geocentric model is virtually identical to our modern understanding, it just reverses the reference frame. 1. The geocentric mechanism, the obliquity of the ecliptic. To an ancient astronomer using the geocentric model, a polar night was not a mystery, but a mathematical certainty. Here's how they explained it. The celestial sphere. They viewed the Earth as stationary in the center. The entire sky, the celestial sphere, rotated around the Earth once every 24 hours. A sea, the pole's horizon. For an observer standing at the North Pole, the celestial equator is the horizon. Everything north of the celestial equator is always visible. Everything south of it is always invisible. CH. The sun's path, the ecliptic. The sun does not stay fixed on the celestial sphere. It travels along a specific path called the sea ecliptic, which completes a full circle once a year. Crucially, this path is tilted by about 23 degrees relative to the equator, the obliquity. The explanation: during the winter months, the sun travels along the section of the ecliptic that dips below the celestial equator. Since the celestial equator is the horizon for a viewer at the North Pole, the sun is physically located below the floor of the observer. As the sky rotates every 24 hours, the sun spins in a circle, but because it is on the southern part of its annual track, it stays continuously below the horizon, resulting in 24-hour darkness, polar night. 2. Historical proof, Ptolemy's climbs. We know the ancients found this explanation plausible because they used it to create accurate data tables. Ptolemy II, 2nd century AD. In his work, Almagest and Geography, Ptolemy divided the known world into climbs, zones based on the length of the longest day. XTH, to calculation. He calculated that as you move north, the longest day increases from 12 hours equator to 15 hours, then 20 hours. He explicitly stated that at a latitude of 66.5 degrees, the Arctic Circle, the sun would not set for 24 hours during the summer solstice. Copper